Okay, so vector embeddings, right. They're changing how we search, how we analyze information.
Totally.
But, and I think this is something that anybody who's worked with them runs into pretty quick.
Yeah.
When your data gets big, really big,
Yeah.
finding the right vector,
Uh-huh.
it's a huge bottleneck.
It is.
It's like trying to find, like a specific grain of sand on a beach.
That's a good analogy.
That's where vector indexing comes in.
Absolutely.
And we're going to do a deep dive today on all the different techniques, how they work, what they're good for.
Yeah, help you choose the best one for your needs.
So you can be a pro by the end of this.
Hopefully.
What's so fascinating to me about these methods is they're all about shortcuts, right?
Mm-hmm.
It's about creating like a roadmap.
Yeah.
So you don't have to look at every single data point.
Exactly. You don't have to read the whole encyclopedia.
You can just kind of like zoom in
on what you need.
on the information that you want.
And there's so many ways to do that too, like
Well, let's start with the most basic one.
okay.
Flat indexing.
Right.
This is kind of like the, I don't want to say it's dumb because it works,
Well,
but it's very straightforward.
yeah, you could say brute force.
Brute force, that's the word, thank you.
You're just comparing your query vector
Yeah.
to every other vector in the data set.
Yeah.
If you have a small data set and you really need to make sure you're not missing anything, maybe it's okay, but
Yeah, but when it gets big,
oh, it gets slow.
it gets so slow.
So slow.
So flat indexing is like reading every book in the library to find the one fact that you need.
Right, which nobody has time for.
So then we move on to locality-sensitive hashing, which is a mouthful.
It is.
LSH, we'll call it.
Yeah, LSH, much better.
What is that all about?
Okay, so instead of looking at every single book in the library, what if we divided the library up?
Okay.
You know, we have the fiction section, the nonfiction section,
Yeah.
the poetry section, the mystery section. So we kind of group similar vectors together,
Okay.
and then we only have to search in the section we think our answer is going to be.
Right. So it's faster.
Way faster.
But are we going to miss some stuff?
Potentially, yeah.
So there's a trade-off.
Always a trade-off.
This is where it starts to get, like, you have to really think about your needs.
Yeah. What are you actually trying to do?
What are you actually trying to do? So, for example, if I'm working with, like, user profiles,
Okay.
and I want to, like, recommend similar users,
Mm-hmm.
LSH might be good because it's fast.
Yeah.
I might miss a few, but, out of 1 million users, if I miss 5, it's probably not that big of a deal.
Right.
But what if I need something more precise?
Okay, yeah, then we need to get a little fancier.
Okay, so that's where inverted file indexing comes in.
IVF. Yeah.
IVF, what's that all about?
So instead of just like, dividing the library up into like rough categories, we're going to be a little bit more precise. We're going to cluster the vectors together based on like how close they are in this like vector space.
Oh.
It's kind of like having a really detailed card catalog system.
Oh, I see, I see.
Instead of just saying fiction, it says fiction, historical fiction, romance. It's very specific.
So it's like we have a librarian who can just point us to the exact right shelf.
Exactly.
But then I've also heard about these things, IVF lat, IVF-SQ, IVF-SQ, what are those?
Yeah, so those are like variations on IVF.
Okay.
And they focus on like, okay, we've got these clusters, but how do we actually store the vectors inside? So IVF flat, you just store them all directly, no messing around.
Okay.
But IVF-PQ and IVF-SQ are like, hey, what if we compress this information a little bit?
Ooh.
So we save space, make things even faster,
Okay.
but maybe we lose a tiny bit of accuracy.
I see.
It's like if our library card catalog, one version lists every single book and the other one's like, here's the general topic area. It's faster to look through that one, but you might not find the exact book you're looking for.
This is so cool. Like, we're adding layers of complexity here. We're getting more and more sophisticated.
It's building up, right?
But, okay, let's say our data is so big, it doesn't even fit in the computer's memory anymore.
Oh, yeah. This happens.
This is like we have a library the size of a city.
Uh-huh.
What do we do?
So for that, we need disk-based ANN.
DiskANN.
DiskANN, yeah, basically it's using solid-state drives, SSDs,
Okay.
because those are really good at storing and retrieving information really quickly, even if it's not in the computer's memory.
So it's like we have a digital map of the library.
Yeah.
And we can just like teleport to the right shelf.
Exactly. You're just jumping right to it.
That is so cool.
Yeah. This is great for like if you're working with massive image data sets or video data sets and where speed is super important.
Even if you lose a little bit of accuracy, the speed is worth it.
Exactly. Got to prioritize.
But then we also have SPAN, which is like, okay, hold on, we can do both.
Yeah, this is a hybrid approach.
Oh, tell me more.
Where it's using both in-memory and disk-based storage. So it's like, okay, we have our librarian. They know the most popular books by heart.
Uh-huh.
They also have access to the entire card catalog.
I see. So they can get you anything.
Yeah.
Whether it's, super obscure or super popular.
Exactly.
And it's fast.
Tries to be.
That is amazing.
Yeah, this is good for scenarios where you really need speed and accuracy.
You're not willing to compromise.
Yeah.
And then finally, we have HNSW.
Yes. This one's a little complicated.
This one is, it's like I don't know, the boss level.
Yeah, you could say that.
But you said this is the one, like if you need real time.
If you need real time,
Large
scale. Yeah.
You need HNSW.
So break it down for me.
Okay, so imagine our library. Right. But it has all these like increasingly specific sections.
Okay.
And there's like a team of expert librarians.
And they can just like instantly guide you to exactly what you need.
So this is like, we're not even using the card catalog anymore.
No, this is like you walk in and they're like, follow me.
They know exactly what you want.
I gotcha.
Before you even ask.
Sometimes, yeah, it's pretty wild.
And this is being used for things like real-time recommendations.
Oh, yeah, all the time.
Like if you're shopping online.
That's HNSW, probably.
HNSW is working in the background.
Behind the scenes.
That is amazing. So we've gone from one librarian to a whole team of expert librarians.
We've scaled up.
We have scaled up. This is incredible.
It's pretty cool how it all builds, right?
Yeah, but I think the big takeaway here is
What's the takeaway?
there is no one perfect method.
No.
It depends.
It depends.
You have to think about what is the size of your data set?
How much accuracy do you need?
How fast does it need to be?
Yeah, how much complexity are you willing to deal with?
And then you choose the right tool for the job. This has been such a cool journey. Like, I feel like we've gone from 0 to 60 here.
We've gone from brute force to, like, super sophisticated.
We've gone from brute force to a team of expert librarians.
I like that analogy.
So as we kind of wrap up here,
Yeah.
what's like a question that people should be thinking about as they continue to learn about this stuff?
Well, I think the biggest question is, this field is moving so fast.
Oh, yeah.
What's next?
What is next?
What kind of crazy new breakthroughs are going to happen that are going to let us do even more with our data?
And do it faster.
And do it faster, of course.
This is an exciting field to be following.
It is, that's for sure.
All right. Well, that's our deep dive for today.
Thanks for having me.
I'll see you next time.
See you later.